Hello and welcome once again to episode 70 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So Spencer, I hear you've been using a certain framework a lot recently. Care to elaborate?
Yes, I have been deep back into SwiftUI after a very long hiatus. I finally got, assigned a feature in my day job, and it was UI related. And I honestly, probably haven't touched UI in 6 months or so, and so it was a nice change. But also, I was like, oh no, I don't remember anything. And so I looked at, our storyboards and everything, and I was like, do I want to touch storyboards again? And so I decided to implement this new thing in SwiftUI, which the last time I did something UI related, kind of as a larger feature rather than just kind of fixing things up, was also in SwiftUI. So it was interesting that I kind of gravitated to that first, I suppose, as opposed to being like, okay, now I need to remember how to, do things on a storyboard and constraints. And, to be clear, I think I could do it. It's been a long time, both in my day job and my personal work, where I haven't done it. So I was like, you know what, I'll give it a shot again in SwiftUI. I feel like I've learned a fair amount since the last time I touched it, and I think I can't remember if SwiftUI has changed since then. I think it's been a little over 6 months, but anyway, I went with SwiftUI, and so inevitably I went to our Rubber Ducky Slack channel and started pestering Dimitri and about SwiftUI, because there was a lot that I had forgotten, and so I thought it would be maybe nice to just kind of go over SwiftUI in general, but also maybe talk about some more of like the esoteric things that I don't understand. I think probably some other people don't understand as well.
And that's actually quite ironic because I have not been using SwiftUI all that much recently, and I'm back like 100% in UIKit land with constraints and stuff. No storyboards, mind you. I'm not that crazy of a person. Just kidding. So SwiftUI is really great for like doing simple layouts and even doing complex layouts, as long as you're not like architecting an entire app in SwiftUI. That's like the one use case I would shy away from, having used it a lot. There are a lot of good benefits to using SwiftUI over UIKit. So as Spencer said, what better time to kind of go over the whole thing as a whole, so then you can, if you haven't started using it yet, you can get a better understanding of like when you might want to start using it and how to get started, right?
Mm-hmm. Yeah, for sure. I mean, it was really interesting. We have designers, which is great, because I kind of this feature that I'm working on was like, they told me to sort of prototype a UI and stuff, and it took me so long to even try to imagine in my mind what the UI would look like. And then I submitted, and they're like, okay, we're going to tweak it, obviously. But when they came back with the designs, it was pretty surprising how straightforward it was to make it look like the designs, I suppose, if that makes sense. Like, it's got, LumaFusion's UI is pretty really non-standard, I suppose. So, having borders on our views and stuff in a very specific way and setting font sizes, it was really easy. So, I was quite pleased with the speed at which I could get the basic design done, and then, tweaking things like animations and really getting into the nitty gritty, but overall making it look pretty dang close was quite quick, and I was quite pleased with that.
Mm-hmm. And that's typically a nightmare when it comes to actually doing that in UIKit.
Yeah.
Any
Oh,
sort
yeah.
of like custom UI work where every little bit is slightly different. Like if you have all the same buttons, then yes, you make like one button subclass and everything's fine. But anytime you need to like tweak this layout a little bit or tweak that layout a little bit, it's like very quickly a nightmare to deal with. So to get started, let's actually discuss like what SwiftUI is, because it is not really what UIKit is. They are like serving two very different purposes. Namely, SwiftUI is very much a layout engine, and it's not actually doing much of the heavy work when it comes to putting stuff on screen. It still actually punts that to UIKit for the most part, but SwiftUI is making decisions about like what should be a view, what should not be a view, in terms of an actual thing that's composited by the GPU. So to get into that a little, let's compare UIKit and SwiftUI. So UIKit is what I would call a compositing engine. So it uses core animation under the hood to set up a layer per view, basically. And a layer, if it has contents, then that layer is going to be a texture on the GPU. And those textures, you kind of just like arrange them and then flatten them, and you have an image that you can show on screen. So that's the conceptual like mental model that you need, but that's also like what is happening under the hood. Your app isn't necessarily doing the compositing on iOS, like that's taken care of by the Windows Server or Springboard in this case, and that has changed recently in macOS as well, where you no longer are like rendering your own views. You're just telling the system, hey, these are my views, and then the system will render them as it needs to. So UIKit kind of forces you to make decisions about what should be a view, what should not be a view, what should get a texture, what should not get a texture, basically, which is fine at a low level. But from a high level, it can get in the way. Like Spencer said, like if you need to put borders on different shapes that kind of surround different elements, that is a nightmare because now you have to have a view that's dedicated to doing that. And that is a lot of work and a lot of boilerplate to set up properly, even if it's possible. Like anything is possible with UIKit. It's just how much work do you want to like spend doing simple things? This is especially like made noticeable when you have other layout engines on the web, for instance, that just take care of all these details for you and you just don't think about them. Things like CSS properties and stuff like that just magically just change the layout. And you don't really have to think too much about that. And I think that's where SwiftUI kind of aims to go. So a view in SwiftUI is very much not a view as you are kind of used to thinking about it. It's just a model of what that container represents. And then it's up to SwiftUI to decide, hey, does this get a texture? If it does, then great, we're going to make an actual UI view to back it. And there's going to be a layer involved. If it doesn't need a texture, if it's just layout information that you're propagating back and forth, or display information like what the font should be and stuff like that, then that information does not need a view. So SwiftUI can go ahead and optimize it away. This is actually kind of interesting because on macOS, AppKit actually does a little bit of this. A view doesn't necessarily always get a layer, and it's up to the view to say, hey, I don't need, like, I can be composited into my parent's layer just fine. So you don't need to give me a layer, and AppKit can actually optimize a lot of that away, but on iOS, that's never really made it. So I think SwiftUI kind of brings a lot of the modern affordances that we're kind of used to from the web over to native development land. And that's why I really call it a layout engine, because that's all it's really doing. It's determining layout so that way UIKit, which is still being used under the hood, can go ahead and display all the views that you've kind of described, right?
Yeah, it's pretty cool. It's pretty powerful to be able to just kind of tell it, like, kind of give it a recipe and say, like, this is what I want, go make it type of thing, rather than you being so granular and saying, like, I will, basically to the pixel tell you what it needs to be. But one of the things that I was trying to do was make this kind of overall, I guess you could call it a view controller. It's being kind of presented as like this little pop-up window, so it's not taking up the whole screen, but make those views size correctly. And so I try not to have very specific, like, quote-unquote constraints to the size, like a fixed size for any of the views, but rather say, like, hey, if the width is like 300 pixels on an iPad, great. If it's bigger or smaller or whatever, just make it work. And it was really quite good at doing that, where you could do that with constraints in UIKit. But again, I feel like it may have been a little bit more cumbersome, if that makes sense. I'm not sure.
Yeah, there's definitely a lot of boilerplate with constraints in UIKit, right?
Yeah, exactly.
And understanding like that whole layout engine, right? You need to be comfortable with it before you can be practical with it. And if you're not comfortable with it, then it's like very hard to get doing what you want it to do. Like I remember anytime anyone starting with app development would eventually hit a brick wall and say, like, hey, my view controller or my storyboard, I don't know what's going on anymore. Nothing works anymore. Like I added one view and everything's broken. And you take a look at their constraints and none of them are described in a thoughtful way. Like they were just added for every view, not really understanding like how they actually interact with each other.
Right.
And when you use them that way, sure, you're going to get what you get when you like drag it into the storyboard, but you're going to have no idea of what's going to happen when the view size changes or when the content changes. Like it's all up in the air because you didn't design the constraints just like you designed the views. You just kind of slap them in. SwiftUI has a very different set of like constraints there, and a very different way of thinking about the layout. So it's definitely a different thing that you need to get used to, especially if you are coming from the world of constraints. But circling back, you mentioned basically how you wanted to use SwiftUI like for a very particular use case. Thankfully, SwiftUI comes with a UIKit controller, right? A UIHostingController. So do you want to talk a little bit about that?
Yeah, I mean, that's the good part. Just like our topic last week, you don't have to like go all in on SwiftUI and, refactor your entire app's UI to use SwiftUI, but it's just natively kind of intercompatible with UIKit. So most of our UI, except for that keypad I was working on last year, and a couple other things that Andrew Madsen was working on, are SwiftUI, and that's it. The rest is UIKit. So our app is very, very much UIKit. But the good part about that is there's kind of this bridge, which is UIHostingController. That essentially, I guess the easiest way that I could describe it, that as well as I understand it, is you initialize like a SwiftUI view, and then you add it as a subview of this hosting controller, and you can sort of just treat it as like a normal UI view. And then, from there, you're able to present that view controller however you want and everything. And it's just, to the user, there's no discernible difference between what is a SwiftUI view and a UIKit view.
And all you really need to do that properly is follow like UI view controller containment, like, hey, we'll move to controller and stuff like that. And that's just so that way event propagation happens. But even if you're lazy about that, I do recommend keeping your overall like infrastructure of the app as UIKit. Like it's very tempting to just go with the SwiftUI. Oh, hey, let's make an app, and then there's a window group, and we're done, right? Because you actually limit yourself severely whenever you do that, because SwiftUI can't do all the things that UIKit can. But if you use SwiftUI for like independent screens or like underlying views, then all of its strengths really come out, because you can get very creative with your UI at that point without like being held back by UIKit. And then you're not held back by SwiftUI because you can get creative with how things are being displayed, transitions between things with UIKit that's not available in SwiftUI yet, right?
Yeah, that totally makes sense. It's been, I mean, the integration of the SwiftUI views into the rest of the UIKit app is super easy. Like you said, it's, just as easy as really putting it in that UI hosting controller, calling a couple methods to for the life cycle, and then you're done. So that has been the nice thing, especially with our app, is like I've kind of already mentioned this, but just getting that custom UI done really quickly. The functionality of what I'm trying to do is not hard, and it's mostly already implemented, like from before I even tried this. It's just we're making a nice UI for the user to do the thing that it's going to do. So it was really just like a design thing. So being able to, design that in SwiftUI and then drop it into the rest of the UIKit app is pretty dang nice. So.
And one thing I didn't really realize when I first started using SwiftUI, because I was mostly all in the SwiftUI part, is you can actually modify the view that you give to the UI hosting controller, and you can just swap it out. As long as it's the same view type, you can just give it a new instance, not even an instance, a new copy of that view, because views in SwiftUI, if you remember, they're structs, right? Mm-hmm. So any changes to them is just data at that point. So you can give it a new copy of data with new values for its properties and stuff like that. And then UI hosting control will just do a regular SwiftUI layout update from that point forward. And it won't even necessarily update everything. It's not going to throw away anything that didn't change in that process. So if you are using UI hosting controller, do know that you can bring in information from the outside just by resetting the content view anytime the information changes. Like, you don't need to hook up anything complicated with an object that is seen by both and stuff like that. Like, you can keep everything stateful and just swap it out whenever an external signal changes, right?
That's interesting. I've not thought about that. I'm just trying to think of like a time when I would do that. Like you're saying, when some external state changes, but.
So I needed to do that very recently because the scroll view that SwiftUI provides is very convenient, but it is lacking a lot of the features that a UI scroll view would have. So I needed to wrap a UI scroll view and have the contents be SwiftUI. So the contents needed to be a UI hosting controller, but those contents need to be dynamic. So I needed to change them, like as you're scrolling, for instance, just to get the scroll position, or to pass in a binding for the scroll area, or the current, like where you want the user to be scrolled, all of that. So like I was struggling a little bit. I was like, okay, how am I gonna like data this out? And then the stupid easy solution was just make a new contents with like whatever signal you want, be it an environment or just a property that you're passing in. Anytime the scroll position changes, tell the UI hosting controller, hey, here's your new content view, and then move on from there. And that worked super seamlessly. And it seems like it's designed to do that. It's just not super well documented, which is unfortunate.
Well, yeah, that seems like more or less the, well, I don't know about now. The documentation seems okay, but I remember like when WWDC of whatever it was, 2019, 2018, when SwiftUI came out, there was zero documentation. So, hopefully it gets there. Okay, so going back to the concept that like views are like a recipe, when you gave it an entirely new instance of that view struct, it still probably, like you said, kept a lot of the things around. It just recognized the changes to whatever it was, and then it didn't have to, create the entire a new set of views, quote unquote, like that whole view hierarchy. It just said like, oh, here are the things that changed, and let me modify what I already have, type of thing.
Exactly.
That's cool.
And that's the key secret to SwiftUI that I think people don't realize. The views are not views. They're models. You are just passing around data that describes how to lay out your system. So they are super, super cheap. And as a result, if something doesn't change in a hierarchy of a view, then it's not going to bother like redoing that hierarchy. It knows, hey, it's the same. I'm not going to touch it. And this can either like be a great benefit or very confusing depending on what you're trying to do. But that's like the key secret here that people try to like staple on. Oh, we're going to have our own view models for our view model because it is already a view model. Like let it be your view model properly. It's just conforming to a protocol that lets it can like work with SwiftUI. So that conformance can be in a different file if you really wanted it to, right? But it is your view model, and it's important to treat it as such. Something that, as you were saying, like it very much is a recipe, and that recipe all happens in that body property. So every view or every SwiftUI view describes a body, and that's what its contents are. But that body is not actually called until SwiftUI is ready for it. So your view up until that point is just its properties. That's it. So that body is where the magic happens. And you're not actually writing regular Swift code in it. You're writing something called a ResultBuilder. And you're composing a bunch of other SwiftUI views, which the view builder knows about and can compose into a proper type that can be returned from the body. So do be careful. This is not regular Swift. You can define variables, but you cannot necessarily do anything. So you can't just have an if statement that does some basic control flow. It's just not going to work. Similarly, you can't have a for loop or a while loop in there either, because it's not going to know what to do with that, because the view builder has to implement like every specific piece of UI of Swift syntax that it wants to support. And it doesn't have to support everything. So that's one of the limitations of like the system. It looks like Swift, but it's all of a sudden not Swift. And that makes it kind of confusing to newcomers, especially when they think it's Swift. So if it's easier to think of it as this is a separate language that's specific to SwiftUI, and there are certain rules that you just need to know about and don't carry over your existing knowledge from Swift over to it, then that kind of works well, right?
Yeah, I think that was a huge thing when I got started with SwiftUI. Again, like the week of WWDC, that first thing was, there's no commas between different objects. You're not returning anything. It's very much, it's using like the DSL feature, right? Where you can have like a domain specific language in Swift. So, like you said, the syntax is different, and again, you're not able to use for loops and while loops and everything. So what kind of helped me were a couple things with that, where one, when I first started, that body just got immensely huge. Just, maybe you don't separate your views out into separate view structs, or regardless, it can just get kind of long. And so one thing that helped was using like view builders to essentially break that out into like, maybe I've got, a top header kind of section of that overall view that I'm trying to make. Well, you could use a view builder, and I'm sure we'll get into that in a second, to kind of build that out and then just call that function in the body itself. And then it's kind of self-encapsulated. And that was really nice. Another thing was, like Dimitri said, you can't have really any logic in your thing. So if you needed to, compute some value, you'd have to either do it like inline of, the argument to some view initializer or whatever, and that sucked. So what I do, and I don't know if this is the greatest thing to do, but is just pull it out into a function that does all the work, and then call that function in the argument to make it look a little more nice, where you're not having to maybe use a ternary operator or something kind of inline to have whatever that logic is.
And the Swift compiler is actually happier about that, because as you're main view body gets like more and more complex, it has to magically figure out what the return type is, and the return type is not evident because there's generics all over the place. So it sometimes just throws its hands in the air and says, "This is too complicated for my small computer brain. So go ahead and like, please make it simpler." Which is actually a good hint to you that you've made it too complicated as a developer. So as Spencer does, I definitely make computer properties, make functions that will themselves return either data or views, and that can help like really structure everything in that one chaotic body. And something I've even done is made functions inside of those functions to handle like subparts. Because a neat thing about modern code editing is you can just fold a function. Like you can put it out of your like way. So if everything is kind of grouped like that, it's very easy to find it when you do need it. And it's not necessarily split across many different files and stuff like that, where it's hard to find. So if you do have related stuff, you can definitely organize it like that. That actually goes into how I like to structure my SwiftUI, and that is a concept that I like to call screens and views. Screens are what you would typically have made a view controller for in the past, and they should be very simple in terms of layout. They should just compose the general views that make it up, and those general views would either be computer properties or themselves proper views that are declared in like another file if they're reused anywhere. But this means that your screen has a very simple body that is clear and easy to understand, and it has all of the data that can correspond to all the interaction between all the different components in that body. Now, that becomes your view model that you would typically think about, and it's also where any business logic about the controller would live. Whereas the individual views that might be like a deep nested stack of like H stacks and V stacks and all sorts of crazy stuff, that can be its own separate thing. You can hide it in a different file. You don't need to understand that to understand the screen. So it can take care of that, its layout on its own, and have like one or two data points that it uses to populate that. But it doesn't need to be all encompassing, if that makes any sense.
Yeah. Yeah, no, absolutely. And I'd love to kind of maybe after the show see maybe some examples, or whenever. It's one thing that I've tried to do a little bit differently than the last time I used SwiftUI in like production code, is really trying to make things as kind of generic as possible and reusable. Like Andrew Madsen did a fantastic job, of course, of doing that in his own code. So one of the things he built out was like a simple selection menu, but he made it in a way that, it doesn't work for just like the feature that he was working on, but it works, I could pull that into my own code very easily. So I've been trying to do that with this thing, kind of like a popover style thing. And I feel like I'm maybe on the right track of kind of having like a screen. And what did you call the other ones? Just views?
Just views, yeah.
Just views. But I don't know, that's, I think, the part that is maybe the hardest for me is having a lot of what you're making composable and reusable as possible. I mean, maybe you don't need to do that if it's a sort of one-off thing, but I think that's probably kind of a lot of the point of SwiftUI, is to kind of have that reusability and have things be generic in a sense. So until you get to a very specific view, and then you can start, doing your specific stuff. But that's a hard thing for me. So, yeah. So let's go over, like, I think one thing that's hard, kind of maybe along the lines of kind of having those generic views, and then also getting into the more specific views, is like, okay, maybe I've got this thing that's like specifically for, I don't know, editing a photo or whatever, right? I'm like, okay, I've got this generic view, but I'm going to pull into this view that's like specifically for editing a photo. And maybe I have some like state variable that I want to pass into my more generic view. I don't know. This is contrived, as are all of my examples. It's becoming a
they're on the
common
spot
theme here. But you've got like state variables, you've got state objects, you've got environment objects, observed objects, bindings,
all sorts of things.
All sorts of things. They've got this weird @ sign before them that you've never seen before.
Their email addresses, right?
Oh,
or are they Twitter
sense.
handles? I'm not sure.
Yeah,
Whenever I use them on Twitter, they just go link to people's like usernames. So like I just assume they're Twitter handles this whole time.
That's a good username. Someone I'm sure has stolen all.
They all
of them.
exist.
Do they?
Yeah. So if you copy paste Swift code into Twitter, everything turns into usernames.
That's awesome. So can we go over them and kind of talk about like, I don't know. They're confusing for sure. Like state object, definitely. And, you've got observed object and what are the difference between those things? And like, it feels like there's a little bit of combine in there and maybe not. And it's confusing to me for sure.
Yeah. So all of it is combined actually. It's not actually
right.
SwiftUI. But let's start with the simplest thing. Simple property, right? A property on a view just describes like some data for that struct. Because remember, a view under the hood is just a struct. So that data does not persist long term. It is for that copy of the struct that you just built. And what SwiftUI will do every time it lays out, it's going to build a new copy of your struct. Anytime you say my view open close parentheses, you're not doing anything special. You're just building a struct at that point in time. So any properties that you have, those are going to be rebuilt like at that point. So you cannot use them for long-term data persistence across like the visual view that's on the screen. You might think, oh, hey, I have a button, and when you click the button, I want to increase a counter. You can't just tell that property to increase. In fact, if you try, the compiler is going to start complaining and say, hey, you're trying to mutate something and you're in a non-mutating context, and this is like not going to work out for you no matter how much you try. So then you might say, okay, fine, I'll make it a class. And then that has its own like host of problems. So SwiftUI gets around this by making a whole bunch of different property wrappers available. So that way you can go ahead and hook things up properly. As I said, you have properties, and properties, you can think of them as constants from your view's point of view. They're variable from the creator's point of view. Whoever's creating your view can pass in whatever they need, but from your view's point of view, they're not going to change. So they are basically the basic settings that someone has configured your view with, so that way it can go ahead and show what it needs to show. The more that you can have as these regular properties that your view is not mutating, the better, because that makes it really simple to kind of compose things. You might start your view off as a computer property that's using its parents' properties, and then once you decide, hey, I need to move this like whole subview is getting like way longer than the main body, let's go ahead and pull that into its own struct in a different file. So you do that, and then you can bring over just the properties it needs over with it. And then whenever you need to make that child view, you just pass in those properties and they just kind of flow downwards. So that's the simplest thing. There's a more complicated version of this called an observed object. And this is a special type of class that you can also pass in. So it is not something that the view itself will kind of like readily keep track of. But if you pass it in externally, it can use an observed object to do magical things. Namely, anytime the observed object changes one of its published properties, then your view will get a free layout pass. So this way it can go ahead and do something different potentially. It doesn't know yet what is going to be different, but when the body is run, it's going to take note of which published properties of the observed object you called, and it will go ahead and say, okay, this part changed, and this part didn't, and then this part over here changed, and whatever changed, it's going to continue down and call body and build out a deeper tree of changes. So all that's taken care of for you. So you have regular properties and observed object. They both come from external sources. That's the key piece. Never make an observed object within your view and expect it to stick around, because the next layout pass, that observed object is going to be a brand new observed object. It's going to be a different instance than the one you started with. So it always needs to come in externally. Now,
Yeah,
what happens? Go ahead.
Oh, sorry. That's so, yeah, okay, well, story time. Yesterday I spent most of the afternoon trying to figure out why the selections to cells in my list didn't stick around once I kind of hid them by closing kind of it was like an expanding and closing cell. I have an observed object, so I'm sure that's probably why an observed object that like holds a set of cells, or yeah, I can kind of identify which cell is selected, and that's probably why, because the arrays or the set is probably getting reset every time that reloads. So thanks for solving my half a day's worth of work.
No, I equally spent many days like tearing my hair out, like frustrated. Why is this not working? And it's because you learn those lessons at that point in time that you remember to never forget. This comes in from an external source. And that's something that I think no one really talks about. Like, we like to talk about solutions in terms of like teaching programming. Is like, hey, if you want to do this, use this, or if you want to do this, use that. You don't understand why though. So it's very easy to like conflate that information a little bit. And as a result, not understand why it suddenly stops working when you forgot that key piece that it needs to come in externally, because you're going to forget eventually if you don't have a strong signal in your head that's like ringing the alarm bells whenever you try to do something. And that's like what comes with quote unquote experience, is having enough of these horror stories that you're never going to forget.
Yeah, it's just like, how we tried to drill translates auto resizing mask into constraints into our students' heads. It's just like, I promise you this will bite you in the butt.
I never forget. Like, I will never forget to put that. It's automatic. I make a new view. I type that. I set it to false. And I go on my way. I activate my constraints. It's just muscle memory at this point. It's no longer an issue of like, people like to post memes of like, oh, it's been 0 days since I forgot to type this. No, it's been a full year since I forgot to type that, because I have been burned so many times by it already that it's no longer an issue. So be burned by your code, because you get scarred enough. You learn from it. You learn very quickly, and you can memorize techniques, and you don't have to look them up. And it's super practical to be good at what you're doing as you improve. So do try to improve, even though like many people say, oh, hey, on your free days, you don't necessarily need to learn about programming. That's true. But at the same time, you should strive to improve, because that will make it easier for you to do the work that you're doing. Right. Yeah,
for sure. I think maybe not for everyone, but that's something that like I've been happy with, where I can also have programming as a hobby. And I mean, I'm not programming every day. Dimitri and the rest of the code completionists know how much I play Smash Bros. Like, I definitely do other things. But I will also spend time, working on my own personal stuff. So it's good when it's like that. It's not always like that for everyone, but can be nice. Okay, so...
We got half of the story in terms of data.
I was going to say we didn't get everything.
Okay, so the other half is at state and at StateObject. Now, these never come in from external sources. You can set the first version externally, and this is where I think people get super confused about them, because they're like, hey, like, it worked the first time, and then my view is there, and I keep telling it, here's a new value, and it's not using that value. And it's probably because you're using at state or at state object. When do you need to use at state or at state object? Well, anytime a part of your view needs to mutate itself. So it needs to modify a property. Say you have a button and a counter, and you want to update that counter needs to be an at state. Similarly, at state object is like a combination of an at state and an observed object, in that it's not that you can't make an object an at state. You totally can. It can be a pointer to an object, and it's going to be happy with that. But it's not going to magically know when its published properties change. So that's where StateObject comes in, because it gives you a hook back towards the view to kind of tell it to relay out. So that's something that's important there. Now, at state and at state object don't actually live in your view. They are, what lives in your view is a pointer to something that lives in SwiftUI's system that's going to be kept up to date with your view's existence. So if your view becomes available, your state becomes a thing. And if your view no longer becomes available, your state also gets destroyed. So that's something important to think about when it comes to state and state object is this is data that is deeply tied with your view's presentation on screen and not the view as a struct. So when you create the view the first time, that state is going to be created with an initial value that you can provide externally, but that's kind of a trap because then you might assume that, hey, on the next layout pass of my parent view, I might provide a different value, and then the view is not going to get that new value because it has no idea what it is. So that's something that you should keep in mind when you are using @state and @state object. There are ways around this. For instance, you can pass a new value as a regular property and then update your state on appear with that property. Like that's something totally that you can do. And that will update your state, but it's only working because you're doing it in on appear when the state is actually tied to a reference. If you update it before it's tied to a reference, then like nothing is going to happen and that value is just going to be thrown out because the state already exists. So those are the key differences between like the main data types. And you mentioned a few more. There's like environment object and environment. And these can all come in externally from a parent, but not necessarily specified by the parent. So it can come from much higher in the view hierarchy. And this is a very convenient way to do like dependency injection. Anytime you might have a singleton, instead of having a singleton, make it an environment object, because then anything that needs it will crash if you don't provide it. So it's like a good reminder, like, hey, you forgot something. But that also makes it super easy to mock and test because you can just, for instance, I love to do this for networking objects, where I'll make them an environment object and I'll make a wrapper or two to like make it nice to read. But I'll make a separate mock instance that's specific for previews. So that way my previews always have data. And they don't actually have to make a network call to get that data. Whereas the app is going to have an environment object at the root of the UIHostingController, and that one will be tied to the app's instance that it's passing around. So that's always the same network object that knows when it's logged in, things like that. So that's a very clear way of like differentiating how you're passing down values. If it needs to go down like several chains, you might want to consider an environment object if it's an object, or just an environment if it's a regular struct value of some sort, like a simple piece of data, basically. If it's more complex than a piece of data, it has its own state that it's keeping track of and stuff like that. And it has business logic, then use an environment object. But yeah, otherwise you can use just a regular environment and like propagate that information downwards.
Okay, so I was also using an environment object just to pass a simple value kind of down this chain of views. And I kind of did that because I felt lazy and I didn't want to pass a binding down all the way. Is that okay? Or should I be using a binding kind of all the way down, or does it really matter? Does that make sense?
Yeah, so we didn't even talk about bindings yet. Bindings are a way of passing information like from the child's view up to the parent. So for instance, an excellent example of this is a control, like a text field. If you need to tell a text field, hey, here's the value you should have, and the text field can put that in there. And then the text field needs to tell you, hey, I modified this value, here's the new version of it. So that information propagates back up. So it's really just a pointer to the parent's data structure.
Right.
Now this gets a little complicated when you're like trying to set it up in your previews and you're like, I don't know what to put. There's a simple like shorthand for that, .constant. .constant is a pointer to something that does not really exist anywhere practically. But from your view's point of view, it's going to behave like a state, and it can go ahead and update that. but there's no like external listener to that information. So a binding is just like a pointer back to the parent's like version of it, and it allows the child to modify that. If you need to go several chains down, as you said, binding is probably not the thing that you want to just like chain all the way down. And you might want to think of a more proper data model, like an environment object, that can go ahead and propagate that upwards. So I would say that's probably fine. You won't be able to do that with an environment. But yeah, with an environment object, that's probably totally fine. There's a separate thing that you can use called preference keys, which I have honestly like used once and not have delved too deep into, but they work very similarly. So you can set a preference key at the child, and then at the parent, you can accumulate all the children's preference keys and decide what to do with them. Do you add them together? Do you take the average? Do you take the first one? Do you take the last one? Whatever you need to do, you can do that. And then it will cause a relayout because you change some value. But you can go ahead and influence the layout in the other direction with this. There are some caveats there, like it will go ahead and complain if you do it too many times per frame, and you can get stuck in like a layout loop, basically, and that's what the complaint is to warn you about that. But that is another way of organizing that.
Interesting. Okay. Yeah, I mean, really, the reason that I went with an environment object was because, you know, you put like at environment object, whatever your variable is, and you don't have to give it a value. When you initialize it, it just like figures out, oh, from the parent, there's an environment object of the same type. And probably the same name. I'll just grab that. And that's, I think that's super cool. So maybe it was out of laziness, but it sounds like it's okay.
Yeah, it's based on the type, right? So
right.
Whatever type, if you have like a network session like class that's an observed object, that's an excellent candidate to make an observed object. I would make a extension on View that's just called like .network session that just takes a network session. And this way you're not typing .environment object and then like passing in the network session. You have something nicer to read when you're like looking over the code afterwards, but it's a simple wrapper. All it's doing is calling .environment object. And all the subviews, you still have add environment object to handle that. I didn't really look into like making special sugar just for that part as well. But for the most part, that I would highly recommend over any singleton idea that you've had in the past. Anytime you have like one single object in most of your app, or even in certain parts, like you might have different objects, as long as it propagates an entire hierarchy, that's a good candidate for that.
Okay. Going back to, when you said it, it made sense, but I didn't really think about it like that. Where a binding is really so that a child can pass data up to the parent. That totally makes sense, like in the context of a text field. But I was just thinking like, oh, I need to get some data down to the child. With an environment object, it can still perform that function of kind of propagating the information up to the parent, right? Because the parent would also have that, and it could be, those changes could be observed.
Yeah, so you can have a state object at the top at the parent that's an observed object, and then the parent will in its body say .environment object, that state object, and then from that point forward, the parent knows. Any intermediate children that have at environment object, that they would know because it's an object, and then the deepest child would be able to inform the parent that, hey, here's a new version of the data that we can propagate upwards, right?
Okay, cool.
So I think the last thing, like, we probably want to split this discussion up because we've been talking very much about the data model, and there's like a whole bunch of stuff we can talk about layout. So maybe we can do that next time. But as a last point that I wanted to bring up regarding the data model is be very careful about like abstracting out a view model of like all your data and all your properties. It might be very tempting because, hey, your view is a view and you need something that's special for the view to kind of inform it how to display. But if you think of your view as very much a like either a screen or a view, then it makes it a little easier to differentiate how much data to propagate. If it's just a view, the least amount of data, the better, right? You don't want to give it a huge data model and say, hey, pick and choose what you need. That's kind of like what we're doing with environment object in a way. But for the most part, that is an excellent place to just have like one or two properties that the view needs, and that's it. At the screen level, that's where you want to just have all your properties. Because outside influence, it doesn't need to tell the screen, hey, you need to have this. The screen is kind of determining that as you interact with it. So if you have one input for the screen, that's fine. And then the screen can go ahead and propagate everything else. That's I think, the ideal. If you do really want a view model, you're going to run into some issues. Namely, one, you can't use SwiftUI's environments at all. You can't do any sort of dependency injection via that, because, hey, your view model, not part of the view chain and the view hierarchy, because the view hierarchy only becomes active within that body. It's not even active anywhere else. It's only when you call stuff from the body, that's when it's alive. But if you're in an init, completely useless. So a lot of people might say, hey, I have a view model. It's a at StateObject, or it's an at observed object, and it has a whole bunch of business logic. Move that business logic over to your screen, because then it can interact with the view more readily. Namely, it can go ahead and tell certain views, hey, there's an alert, or there's an error. It can set states, it can set environments, it can check environments. It can do all sorts of things where you're much more limited if you have it in a view model. That said, if you do want it in a view model, you need to tell your view model every time your view is refreshed. Basically, you can do this in onAppear and onDisappear, or the new .task in a way. But in onAppear, you can tell your view model, hey, this is the new view. Nice to meet you. It's going to be a brand new one next layout pass with a whole new set of properties. But at that moment in time, all the properties are set up. All the environments have values. All the states have values. Everything's interactive. So that's a good time to kind of pass that information through. But you do need to pass it through. And that's something that's non-obvious, because it's not really a pattern that SwiftUI encourages. So if you do want to have a view model, it should be strictly data. It should not have any business logic. It should not do anything. It should just encapsulate the data as a whole, so that you don't need to have a first name, a last name, an age. You don't have to have all those things as separate properties. You can just have a single user like model that has all those individual properties in it. That's like where you should be leaning towards in terms of like a view model. It should not really be a coordinator of any sort that kind of does stuff. That stuff should be kept in the SwiftUI screen. And as long as you pull out all of the subviews from your screen can dedicate itself to that business logic and be a proper controller at the end of the day, right?
Okay. Yeah, that makes sense. Interesting. I will have to think about that. I don't think I was doing anything like that, like that observed object that is kind of this problem. All it had was like a dictionary in it, or a set. It was pretty straightforward. But so if I needed to do anything with that set, that would be in my screen, essentially, like when I wanted to send that back to the UIKit part of the app or something like that.
Yeah. Or like a super common one is, hey, you need to make a network request of some sort. Keep that network request in your screen, because guess what? You just got your network object via an environment object, right? It's right there. In your screen, if you have any errors, you can go ahead and update your view to show an error. Like, it's all stateful at that point. Whereas if you hide it in your model, in your view model coordinator, whatever you want to call it thing, then yes, in your view, you can have a button that says log in, and that will tell your view model, hey, log in. But your view model now has to get your network from somewhere. It can't get it from the environment unless you kind of hot patch it through onAppear, and then it might change at any moment. So your view model needs to be prepared for it to change at any moment. And then in your view model, if you get data, then you can set your published properties and that will propagate back to the view. But if you get an error, then you have to have special properties just for an error, which you need to propagate to the view, which also probably has an error to update its view. Does that make sense? Like, you get into a lot of redundancy that doesn't actually help you in the long run. So it's like an over insistence on like, hey, we need to stick to these dedicated patterns, MVC, MVVM, Viper, Coder, I don't know, whatever people want to call these. The thing that I have like learned the most in my career as a software developer is these represent like individual people's like habits more than anything. It just like, hey, this one person, they like to make their code look like this. So that made a whole architecture that they want to call it. So that's why I don't even want to call my mental model of having screens and views an architecture, because it certainly fits under that like that paradigm, right? But I don't want people to like stick to it. It's meant to be broken when it needs to be broken, right? You need to go ahead and use the best tool that's available for the given job. And you need to learn how to identify when a tool is good for a given job. That doesn't mean you should never like take a look and a gander at how different architectures solve different problems, but that doesn't mean you need to stick to the way that they prescribe doing it. It's really up to you to think and say, hey, like, I really like this idea, I'm going to steal it. Swift does this all the time. It's like, I really like operator overloading from that language. I'm going to steal that. Objective-C never had it, never needed it, but it's kind of cool that it's there now. And it makes the language better. So you can go ahead and do that with your own code, and really try not to fight the framework as much as possible. And in this case, like MVVM active or coordinators or whatever architecture you want to call it, actively fights SwiftUI, because SwiftUI is not made under that model. It's made under a SwiftUI model that just doesn't have a proper name yet. So you need to to best use that, you can either choose, hey, I'm never going to use environment, or you can choose, I'm going to use all this stuff that SwiftUI makes available to me, and just work alongside that rather than fight it, right?
Yeah. I mean, I don't know if this is quite the same thing, but, we've talked about like, maybe we've talked about this. I feel like we have, or at the very least, I know that I would kind of talk about it when I was teaching, is like, learn the rules so that you know when to break them and when it's kind of appropriate to break them, but don't just kind of ignore them. So like, MVC is a pretty good pattern. MVVM, I would assume, is a pretty good pattern for most app development. I've never used it, but like in this case, it's like, you know enough to know that it doesn't quite fit SwiftUI's model. And you need to kind of break the rules of like, the entire rest of your app may be using MVC or whatever. But if it doesn't work with SwiftUI, don't use it, because you're going, like, break the rules before it breaks your code.
Exactly. Like, you could totally have MVVM or coordinators for the UIKit part, if that makes a ton of sense to you. And then as soon as you bridge into SwiftUI, just have a paradigm shift and think in a different way, because you're going to need to think in a different way anyways. So may as well use the tools that are provided to the best of their ability, right? This week's episode of Code Completion is brought to you by Pennant, calling all sports fans. Want to keep track of the season, but there's so many teams and not enough time? Check out Pennant. Pennant provides sports standings at a glance. Pennant displays league standings as a simple bar chart where the best teams rise to the top throughout the season. Of course, you can dig in deeper with team stats, game results, and more. Version 10 introduced the all-new customizable My Pennant view, where you can build a wide selection of visualizations for any sport, division, or team. Unlock Pennant Premium to add as many blocks as you'd like, and put any of them on your home screen as a widget. Whether you follow MLB, NFL, NBA, NHL, or MLS, Pennant has you covered, with more sports and leagues coming soon. Thank you so much to Pennant for sponsoring Code Completion. Download Pennant on the iOS App Store today. So as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at CodeCompletion to know when new episodes get released, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who's at Spencer C. Curtis. That's SpencerCurtis on Twitter, for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buñol. That's DimitriBounil, and we'll see you all next week.
Bye.
Okay, so for Commented Out, I wanted to meander a little bit because using multiple computers sucks, and I just want to highlight that as much as possible. You have all your stuff on one wonderful computer with many displays, all your layout the way you like it, everything where it needs to be. But that computer, even though it's a laptop, is not really portable, because once you unplug it, nothing is where it was supposed to be. So you lose out in one avenue of, you had your desk. And although you can shuffle all your desk into one little pile and bring it somewhere with you, that desk is no longer organized the way it was organized, and it's completely useless. Alternatively, you can kind of set up a little camera on your desk and you can see all your desk, but you have none of the data that's with it. It's just a view onto what your desk is. And that is an equally horrible solution. Solution number 3 is you have multiple computers, but each one has a slightly different, you have multiple desks, right? You have different stuff on each desk, but you also have different data, and any notes you took on one may or may not be the same on the other. There are tools that kind of bridge this, notes will sync up and email kind of shows up on everywhere. But other things like code, you have to remember to sync up. So you have to remember to push your changes on Git. You can't just get up and walk away to another one and start working over there. And things may not have been saved on computer A, so therefore they're not available on computer B. So using multiple computers sucks.
Yes, it does. That's very much a first world problem. But yes, I agree. I'm definitely there with you. I mean, I've got, the work MacBook Pro is basically the one that I use most of the time. But then I've got my MacBook Air, I've got a Mac Mini in the other room, and it's and what sucks is for testing, I have, I don't know. Well, I don't have that many right now, but I used to have, I think I have 3 or 4 iPads right now, all of different sizes and everything. And it's okay, now I have to update all of them and run through, make sure they're all charged, go through, you can go into settings, wait for them to download and stuff. And it's oh my gosh, it's kind of a full-time job just keeping up everything, charging and staying up to date and everything. And then, maybe, well, you probably can. I don't have it, but updating apps on the App Store and everything, I don't have automatic updates turned on, so I have to manually go and either jump onto my laptop or VNC into it and update those. And it's just there's a lot of mental overhead of having multiple computers. So,
yeah. And you can add computers to the list to behave as a content cache and make everything a little speedier, which is totally doable, and that's what I have at home. But yeah, going back to the VNC thing, VNC is horrible. It's the
VNC
worst
sucks,
experience, dude. But it's something I want to work so well. I want to be able to be in the living room and just pull up any little laptop and log into my Matrix over here with my 4 monitors and be able to use that. But you can't, because it's 4 monitors and it doesn't fit on a laptop. So it's everything is super tiny. And thankfully we have Retina screens now, so you can actually see it if you have a good enough prescription. I don't. Normal people, you probably gave up a long time ago, but us glasses people, we can dial these things in to see real tiny. So everything else is a super cosmic warp session, as everything warps around you when you kind of get that nitty gritty focus going. And the eye doctor's are you sure you want that? And I'm yes, please. But yeah, it's totally the worst experience. And it should be so good. You should be able to just not need to be tied down to a specific setup, right? Like, we live in an age of computers. You should be able to be on the go. And I'm not saying like from your phone, but like at least from an iPad, be able to pull up stuff that you're like working on and like tweak a little thing one here or there, or check something here or there, and not feel like you need to go through a rigmarole of like ancient technology and a slideshow called VNC to like do anything. Yeah. I'm just frustrated.
Yeah, I agree. I mean, whenever I like VNC on my work laptop from anything, like my MacBook Air or whatever, it's on the stupid ultra-wide screen, and so it's like the VNC window is like the top half of my screen, and that's it. Then I have to like squint and zoom in and like find the display settings to set it to like 1080p so I can actually...
But then all your windows are ruined. It's like...
No, I know. It's the worst. I mean, it would be cool if it would like automatically change the display, but like you said, you know, the windows are changed, then it's like, oh my gosh, dude, there's no... I mean... my solution is to have Dana's ultra-wide iMac, and then my problems are solved, and then I can VNC, and it's the same aspect ratio.
Mm-hmm. I think, what's that new thing? Something control? Universal control? I think that's going to help a little tiny bit with like some use cases where you just have like multiple computers right next to each other. Because then, I guess you can't have like a window span. You can just move the mouse. I was going to say you can have two iMacs and you can just kind of have your VNC.
There we go.
Ultra-wide.
Yeah.
That wouldn't work.
Does universal control work between Macs as well? I know that I've seen people go from like iPad to Mac, or Mac to iPad.
No, I saw this crazy thing on Twitter where someone had like, I don't want to say 10, but it seemed like 10, different devices, and they just like move the mouse along this whole chain. And I'm like, wow, that is so cool.
That's so cool. Oh my gosh. I can't wait for that to be a thing. That'll be so nice. Again, just for testing mostly, but it's such a cool feature.
Mm-hmm. I mean, maybe when we get AR glasses, we'll get like proper VNC where you can just like whole setup, blam, right in front of you, wherever you are. You can just like log into that. That'd be neat.
I was going to say, Dimitri, your solution is the metaverse.
Oh no. Anytime anyone mentions the metaverse, I like remember that super like very weird video that I think someone made. It couldn't have come out of actual Facebook, but there's like Zuckerberg or whatever, and he has like a knife behind him and his like legs are all janky, and he's like, welcome to the metaverse. Would you like to give a cake to Mark? And then it's like you choose no, and it's like you have chosen not to give a cake to Mark, and Mark is there with the knife. It's like this super weird video, and I'm like, where did this come from? Whose mind did this leak out of?
Oh my gosh!
But yeah, that's permanently poisoned my view of the metaverse.
Yeah.
I just think of that every time. It's like no good.